Web tunnels are a new way to authenticate users on the web. With web tunnels, users can log in to any website using SSH. Traditionally, users have to provide a username and password combination in order to authenticate on a website. Passwords have all kinds of security issues, which has led us to a world where everyone needs a password manager. Recently, passkeys are a new form of passwordless authentication, where browsers create a cryptographic key stored on your computer. Web tunnels are like passkeys, but use SSH for authentication. So all the user needs is an SSH key pair to authenticate on the web. Web tunnels leverage SSH port forwarding in order to provide a website that is automatically authenticated with minimal setup. We built an open source library called Piton that helps developers use web tunnels for user authentication. The way it works is simple. The end user creates a local port forward SSH tunnel to a service running Piton. Piton spins up a dedicated web service for that tunnel using a Unix socket. Then the user can access the web service using localhost. The web service can then access the SSH context in order to know who the user is and what they are authorized to do within that service. We created a couple example projects to demonstrate how web tunnels work. Our simplest example is a web service with a single endpoint. All this endpoint does is return the username and pub key for the user accessing it. Here, I already have the example Golang binary running. It's just an SSH server running on port 2222. First thing you have to do is activate the local forward. I can just curl on my localhost port 1337, which is where the web service is running through the SSH server. And here we are. As you can see, it returns my username and the public key fingerprint that I provided when opening the SSH tunnel. You don't need to build web services with web tunnels in mind if you're clever. One of the motivating factors for us was to create a private Docker image registry authenticated using SSH. This is how it works. We build up a vanilla Docker registry container, and then our web tunnel service proxies requests to it and automatically scopes it to the currently authenticated user. Docker push and pull work exactly the same without the need to run Docker login. So what's the result? We don't need to rebuild the Docker registry web service in order to use web tunnels. And all it took was about 200 lines of code. Pico created images.sh. That is our private Docker image registry service. All you need to do is open up a tunnel to it, port 1337 to images.sh. And now we can make bare curl calls to that registry. And it's only going to return the repositories that I own. And as you can see, like the API endpoint, this is just a normal Docker image registry API endpoint. There's nothing special here. I can even find all the tags for a repository. I don't have to provide any authorization headers. Docker push, Docker pull, they all work the exact same. Here's another example. I can do a Docker pull localhost 1337, and I can pull one of the private images from localhost that goes through the web tunnel. With images.sh, you can use Docker push and pull like you normally would. So if we wanted to pull one of the images, that's one, there we go. So I was able to Docker pull without logging in. Let's just pull Alpine latest from Docker Hub. Okay, and then Docker tag Alpine latest with localhost 1337, Alpine latest. Now I can Docker push to localhost 1337, Alpine latest. And there we go. I'm pushing without Docker login. And then if we curl the catalog, as you can see here, now I have Alpine. What makes web tunnels awesome? Authentication happens within the SSH protocol, not the web protocol. No need for authorization headers, cookies, or any login forms. Developing against a web tunnel is so simple, all you need is bare curl calls. You can wrap any web service you want in a web tunnel and make it work. Developers can know how many users are connected to their web service without needing WebSockets or any other HTTP heartbeat.